Welcome to another video on the next step about designing the traffic vehicles and formulation of metrics. Before that, in the previous video we discussed about signal controller. I want to revise it once again. Go to signal controller, and you can see I created a file. Just double click on that. You'll see edit button. You can see, and signal group I have made 8 different signal groups, out of which 1 and 5 works on the similar pattern. 1 and 3 works on 1 and 3 1 and 5 works on together, and 3 and 7 works together, and 2 and 6 4 and 8. It can be visually seen on this picture over here. I assign signal group 1 my green time and red time and yellow time. I made 1 2 3 4 and I mirror it. 1 goes with 5, 2 goes with 6, 3 goes with 7, and 4 goes with 8. And save it, click back, click OK, and you can see I assign the signals for individual group. For this left turn, eastbound left turn, I assign signal 1. For this, signal 5. For this turn, signal 7. For this, signal 7. So signal 7 and 3 works together, so this one is 7. You can make it as 3. Make it as 3. It doesn't matter, but it works on the same. You can give a specific name, and you can just run the simulation button over here, and you can see the two lanes will be these two phases working together. Eastbound left and westbound left. Now this through east direction through and west direction through are operating together, so that you can minimize the losses and do effective design by changing the signal control in redesign section. I have a cycle time of 120 seconds, so you can see a yellow. Now it's green in this direction, left turns, so you can stop the simulation so that you can get some basic idea on your signal, whether they are operating correctly or not. We can ignore that. And today in this section I'll talk about some metrics, origin and destination metrics, and for that we need to go to traffic and go to dynamic assignment and go to metrics. Before that, let me show you the zones, what the zone means. For this, you can see from okay, it's just about parking lot. Let me show you once again the dynamic assignment. You can see OD pair, sorry, you can click on OD pair. You can see the OD pairs. It means that from origin is a vehicle originating from that zone to the destination zone. So from 1 to 1, we assume the vehicle move from this parking lot to every parking lot, and within itself too, from 1 to 1, from 1 to 2, from parking lot 1 to 2. So we don't assume a U-turn, so the vehicle moving from 1 to 1 will be 0, and vehicle moving from 1 to 2 will be 0 because the vehicle don't have U-turn in this. So from 1 to 2 is 0, and we have assigned 1 and 0 relative flow in each parking lot, so it will automatically show 0 in the matrix. And these are our origin. Suppose it's from parking lot 4 to parking lot 4 to 3. 4 to 3, okay, sorry. Let's check 4 to 1. From 4 to 1. So let's see, it will show 0 or not because we don't have U-turns. So for that, matrix, go in dynamic assessment, go to matrices. You can drag it a bit up so that you can see. You can right click, add in. You can start from 0 0. Let's give a time interval of 15 minutes. 0 0 shift 15, sorry, 15. You can add next, next, next. So for 15 minute we can analyze we can count the number of vehicles for 15 minutes and put in the matrix. I'm showing you in second the matrix. This is for first 15 minutes, and for next 15 minutes to assign the time interval from 15 to 30. So from 30 to 45. So from 45 60. 60 means 1 hours. So to make a matrix, click on this, double click on that, you will see a matrix over here. So as I told you, from zone 1 to zone 1 the number of vehicles traveling is 0 because there is no U-turn, so it can't come in same lane back. So from 2 to 2 is also 0. So similarly, from 1 to 1 vehicle for parking lot to itself, the origin from parking lot to itself is 0 for every parking lots. So just this white portions we need to feed the vehicles number count. So for first 15 minutes from zone 1 or parking lot 1 to 2, you can give your design number, how much you got in your design. Suppose I put 15, 165. Suppose 165, and this 12. Maybe in this, I'm just putting random value. You have to put it according to your design. So this is done, so we can close it. And similarly we can do for matrix or other rest matrix. Just double click on that, you'll get a matrix. Put the values for each 15-minute interval. It's just a hypothetical higher number. You can put it slightly lower. So you do the same for 3 and 4. And now you need to add those matrices in your parameters. So go to traffic, go to dynamic assignment, and go to parameters. So click on matrix, add the matrix, add 1, 2, 3, 4, sorry, put it 3 in serial order and put it 4. So make your evaluation time for per 15 minutes. So 15, 900, evaluation interval 900. Make sure everything is same. So for this, click OK. Now you are done with the vehicle inputs. And to run the simulation, we need to check the simulation parameters. Make sure you give for 1 hour 60 minutes, so 60 is 360 so the simulation time is for 1 hour, and the start time is 00 as we said before. It's all default. Click to check the period and check the time, so click OK. After that you need to go to evaluation, go configuration, and click on vehicle performance, enable it, vehicle performance, and click OK. Now everything is ready for the simulation. You can hit the simulation button, save, yes, and you can see the vehicle moving on. Since the design traffic is heavy, it's a lot of delay. You can redesign to change the signal values, green time values, so that you can minimize the delay. So in order to run this simulation quick, you can keep quick mode. Everything will run. You can see the time it will run too fast, and how a simulation could be completed quickly. So after completion of simulation, you need to check the vehicle performance delay, total delay, and summation of delay for each individual. I'll show you in a second after the time is done. It's about to be 3600 because we set the time for 1 hour simulation. So you can ignore it, and you can go to evaluation result list. So network performance, what was the network performance for this run? So total stop delay, demand, you can analyze by looking at the results. So that's all about this project. So you need to redesign or change the signal timing and everything to make sure you have less delay in the performance of it. Thank you guys for watching.